Howdy everyone, it's meteorologist Aaron Treadway again here. So we've talked a lot about different aspects of the weather, and now let's talk about wind. Wind is actually one of the most important elements of the weather because it impacts several different things and plays a key role in how weather changes over time. It's also one of the many elements of weather that we can feel. You know, we feel the wind on our faces when it's windy outside. So let's just jump right on in. So a couple of different notes about the weather. The first is that wind is almost always horizontal. By horizontal, I mean wind almost basically always goes along the surface of the earth, you know, from point A to point B, from Farmington to Albuquerque, something like that. And it rarely is ever vertical. It's rarely ever up and down, but the big exception to that is in thunderstorm updrafts. You know, we've talked about thunderstorms, or we will talk about thunderstorms, and that's a lot of vertical motion, a lot of up and down movement of the wind. Wind is also a force. You know, you might have heard about forces before in physics. It's when an object can act and kind of push on another object. And so we measure the wind by the force that it applies to other objects. And those objects may be airplanes, maybe our faces, maybe flags or anemometers, which we use to actually measure the wind. It's the meteorological instrument that we use. Planes often take off and land into the wind because not only does it help them gain the lift that they need to take off, but it also helps them slow down, you know, when they're coming into land. And flags that we see outside, you know, it's probably one outside your school, point in the opposite direction of the wind. So as you can see the arrow there, the wind in this case would be going from right to left, which causes the flags to blow towards the left. Now there's a lot of things that cause the wind, and the main one is the pressure perspective. So we've talked about high and low pressure already, and in general, wind will flow from areas of higher pressure to areas of lower pressure. So from the big H to the big L, kind of. And the difference in pressure there is called the pressure gradient. So that's how much of a pressure difference is between these two pressure levels. And generally, the greater the pressure difference, the greater the wind, the faster the wind. So if we're talking about two numbers that are fairly the same, close to the same pressure, it's going to result in a smaller pressure gradient and so a slower wind. If it's a big temperature and pressure difference, then we're going to actually see a faster wind because that pressure gradient is higher. So there are three forces that factor into the wind. The first is pressure gradient, which we just talked about. It's basically the Earth trying to say, hey, I want to try to make there to be the same temperature and same pressure across the globe. Doesn't always work that way, but it's trying. The other is the Coriolis force, and this is what causes things to rotate in the atmosphere, and it's actually due to the Earth's rotation. So in the northern hemisphere, it causes objects to rotate to the right, for example, hurricanes. And then last is friction. Friction helps things slow down. Think about your parents applying the brake in a car. The brake puts friction on the brake pads and on the wheel, and you slow down. So friction in this case helps slow down the wind. The other thing is because temperature and pressure are related, you can actually look at temperature differences and discover the wind. So areas of warmer air cause that air to rise and result in an area of lower pressure underneath that rising air. Areas of colder air cause all of that air to sink, and that puts more pressure on the air and causes higher pressure. So, in general, wind will flow from areas of higher pressure to lower pressure. And we see this a lot during the day because that creates these pressure and temperature differences. One example of that is the land to sea breeze. So think about being on the coastline. I know y'all are there in Farmington, not really a coast anywhere near you, but if you were by the ocean would actually not heat up as fast as the land, so it's creating a pressure and a temperature difference. The warmer land creates lower pressure than the cooler ocean, which creates higher pressure, and because of that, you actually get wind that flows from the ocean onto land. Now at night, when things cool down, the land will cool down faster than the water because the water holds that temperature more, and that reverses the whole process, so you actually get wind going from the cooler, higher pressure of the land to the warmer, lower pressure of the water. And so this is what creates land and sea breezes, which can actually help create thunderstorms. And here's an example of that. So here in the middle is the Yucatan Peninsula of Mexico, and it's an area of lower pressure. It's an area of land that warms up quicker. On the two edges are higher pressure, and that's the ocean, which is going to stay cooler longer. So the wind is actually going to come in on both coasts, and you can see that in the movement of the clouds, and then boom, right there, the thunderstorms fire off because of all the wind coming together. And so that's just one of the many examples of how wind can actually help create the weather. So you can actually see the wind on weather maps, and we measure them and we show that by these little pegs with the different wind barbs on them. So if it's a short little wind barb, that means 5 knots. If it's a longer barb, that's 10 knots. And if it's a flag, that's 50 knots. So knots are pretty close to miles an hour. There's a little bit of a difference, but in general, they're about the same. So you can see the different examples here, and on the far side you can actually see a Farmington observation, which is one short little barb and one long little barb. So that's about 15 knots. So it doesn't necessarily mean that it's exactly 15 because we do round those measurements. So it might be 17, might be 13, but it's around 15 knots of wind speed. And you can actually see these on lots of different weather maps. Here's an example of an upper air weather map where up in the atmosphere there's no friction to slow the wind down, so you get faster speeds. Looking at this, right around Farmington, you've got 3 longer pegs and 1 short peg. That's 35 knots. Oh, and there's one of your triangles, which is 50 knots, so it's a lot faster speeds. But you can see it at the surface too. So here's actually that observation of 15 knots right there at Farmington, right near the Four Corners. And here are observations all across the southwestern U.S. These circles mean that there's really not any wind going on at all. Here's 2 longer barbs and 1 short one. That's 25 knots. But what about this one? This green one here is really long. Well, that's actually an error. It's not really that fast a wind. If you were to count all those up, I believe it's over 700 or 800 knots of speed. That's faster than an airplane would fly. So there really wasn't wind that fast, but it's just kind of funny to look at and see all the flags and count them and try to figure out how much wind. But again, that's an error. That's not really wind that fast because you can see all the other ones are about 15 knots. So that's the wind. That's what causes the wind, and that's why wind is important.